Yes, hi everybody. I'm a data science from the Thomson Reuters labs in Switzerland, in Zug. And today I'm very happy to welcome with us Aileen Nielson, who will talk on the subject of evaluating fairness and general fairness considerations when developing AI methods and applications, both from the legal and the technical perspective. Aileen is currently a fellow in law and tech at ETH Zurich. She has a background in law from Yale Law School, and she's also a practicing data scientist in her research and in her work in the private sector. In addition, Aileen is the author of two data science books. One is called Practical Time Series Analysis, and the second one, which is very relevant to her talk today, is called Hands-on Fairness and will be released in July. At the Center for Law and Economics at ETH Zurich, she uses her background in data science to perform empirical and experimental work relating to the interplay between law and technology. Initially, our first idea was that Aileen will visit us in Zug in our offices, but with the latest developments, we will have this talk completely virtually. And we expect a big audience today, so I would like to ask you to mute yourselves at all times, except during the Q&A session, and ideally also turn off your video stream. We will have a plenty of time for questions at the end. You can either raise the question by talking or writing in the chat. And with this, I would like to thank you, Aileen, again for joining us today. And I hand over to you for your talk.
Thank you, Laura. And hello, everyone. I want to thank you for coming to this talk. I want to especially thank Laura for inviting me. I'm really excited to meet you all and to have some feedback on this material or see what is interesting to you. So for me, this is also a great opportunity. So my talk is called Fairness Considerations in Applied AI. And the goal is to give you some overview of all things AI and fairness, and also to think about things both from a technical angle, but also from a legal and ethical angle. And obviously this is a huge topic, so this is in no way a complete talk, but it is meant to highlight some interesting ideas and make people feel better equipped to think about this and apply fairness in their own work. So here's an outline of how we will attack this problem. And actually, before I continue, I just want to say two things. So the first thing is I am not experienced with WebEx, so I apologize in advance if I am missing questions or otherwise doing things that are suboptimal. Feel free to let me know. And relatedly, if you have questions, especially clarification questions that are on point or elaboration questions that are on point with a particular slide, I'm also happy to be interrupted and to address questions on the spot rather than waiting for the end. So I'll leave it to your judgment when a particular question is more appropriate. So this is what I'm planning to talk about. First, talk about the AI fairness problem and convince you that it's a problem. This has been a hot topic at least since 2016. And of course, if you talk to some people, they'll tell you they've been working on it quite a lot longer. But just to convince you mainly that it is still a problem, and that actually what we see so far is a lot of news headlines, but not necessarily much action or even much actionable advice. Secondly, I also want to talk a little bit about defining fairness. This is not as easy as you might think. And as someone working at the Center for Law and Economics, one of the things that interests me is I think we're on a collision course where industry versus technology versus law are going to be working with different definitions of fairness, and that could be a problem. So that's something that's interesting to me. The third bullet point, fairness interventions, that's where I will walk us through sort of a typical schematic data science pipeline, and we'll talk concretely about what kinds of interventions can be done at different stages of your pipeline. And then finally, I'll close just with what I call state of the art, which is just sort of what's going on now, both in the technical and legal worlds, and what does that likely mean for us? Okay, so new system, same problems, unfortunately. We have all heard so much about fairness in AI, but there are still so many embarrassing facts. And this is one of the things that interests me, right, is that this can be such a hot topic. that people can be aware of it like they certainly weren't 5 years ago, and yet that we still have really embarrassing things coming to light in major systems. So not a small startup with 3 people that didn't have time to think about it, not in an industry that's not regulated, but even in things that have traditionally been regulated. And I'm mostly going to take a US approach to this. I apologize for that, but I am trained as a US lawyer. But there are certainly similar cases in the EU. So some examples. On the left, I have a snapshot from a news article, Housing Department slaps Facebook with discrimination charge. This happened just in March of 2019. The underlying behavior with the discrimination charge went back probably about 10 years. And it relates to the fact that in the US, and you have similar rules in Europe, there are certain areas of the economy where we say, okay, any form of discrimination, and particularly what we've seen historically in the US is racial discrimination, is so pernicious and so damaging that the state is going to reach very deeply into private life and regulate this. And where do we do this in the US? We do this with access to credit, we do this with education, and we do this with housing, because we say these items are so important that even in the US, where we are skeptical of big government, we don't like government overreach, we say these are really important areas. So Facebook had a number of alleged violations. I don't think the factual elements are that disputed, but we will still call them allegations. There were a few things. One was that Facebook developed what they called ethnic affinity labels, right? So they weren't actual ethnic labels. Ethnic affinity, which tended to map very, very well onto what your actual ethnicity was. Although because they called it ethnic affinity, they could say, oh, well, maybe you are a white woman who has an ethnic affinity for Hispanic culture. So we would actually give you a high Hispanic culture ethnic affinity score. And maybe they were saying, well, you know, certain products, this could be useful for marketing them. And that already sounds a little suspicious to me, but these things have gone on forever, right? That advertisers have a demographic they want to target. It's not necessarily malicious. What was different with Facebook is that now you're letting advertisers just click buttons, right? So instead of just picking a magazine that's known to have a certain ethnic group that mostly reads it or that it purports to service, you now have a more general platform like Facebook meant to reach everyone, but you are still giving advertisers this granularity. Oh, I only want young white men. Yeah, don't give me any of those older Black women. I don't want them. And people were actually doing this. And where it becomes clearly illegal is, for example, when you're advertising housing. So sometimes people use these ethnic affinity or jobs. And in those cases, it's clearly illegal. So that's where Facebook has been sued by the US government and only settled in the past year. So I find this deeply disturbing, A, because it was going on in plain sight and everyone knew about it, but we didn't see an enforcement action for about 10 years. And B, because when you think about the people who are very much like you, practicing data scientists, building these models, I don't think any of those people wanted to facilitate discrimination, but clearly somewhere along the line, something went wrong in the pipeline, right? Because we can imagine that whoever built this model, if they had known how it ultimately got deployed, probably would have been a bit worried about this. Another example more recently, and I think this investigation is ongoing, in November of 2019, when the Apple Card was released, there was some algorithm, presumably, that was assessing your credit worthiness. And I think within a few days of the release of this card, which was released with Apple, but I also think Goldman Sachs backing it, someone who is a fairly prominent web developer tweeted that his wife and he had gotten drastically different scores, despite clearly having very similar financial backgrounds, in part because they're married, but also in part because of their own work histories and salaries. So these are two recent examples just to show you that A, there are new bloopers, such as the Apple Card, where people would have been hyper aware of this issue. In fact, the finance industry and the credit providing industries are highly regulated, so they should be really worried about this. But B, as in the case of Facebook, we can also see that these things go on in the open for long periods of time without much being done about them. Here's another example. This came out in Science in October 2019. This one is interesting. I'm going to sort of take us through a laundry list of different ways that well-meaning data scientists and product developers run into problems nonetheless. So in October 2019, a study was published The headline I'm showing you was a write-up of the study. It wasn't the study itself, but it told us that millions of Black people affected by racial bias in healthcare algorithms. There was a fairly large US health insurance provider, and their program had started out seemingly in a good way. What they had been trying to do was to develop a model of who was most likely at risk for having significant health problems. And the idea was that they were going to reach out to those people who they insured in a more active way. And so this has a self-interested component, because if I can catch somebody's illness earlier, I can probably lessen their costs. So I, the insurer, want to do that. But it also has a beneficial component, right? Because even though my insurance company, if they target me for this, they are saving money, but they're also probably helping me improve my health, right? So clearly it's beneficial for them to decide that I need outreach if I, in fact, do need outreach. And so they were identifying patients for personalized interventions using what turned out to be a racially discriminatory model. And that's what the problem was. Race was not explicitly factored into the decision. So it's not like, for example, that Facebook case in the previous slide where actually you just had an ethnic affinity score that was being used when it probably shouldn't. But the problem is that healthcare spending was the proxy they used for need. And this is very understandable, right? We have all sometimes been asked to build models. And sometimes these models sort of come down from a higher level where maybe people don't understand the limits of what can be done. And they say, oh, build me a model to identify at-risk patients, right? Sounds very reasonable to the business executive. But that probably came down the pipeline to the technical people. And they looked at that and they said, okay, well, in theory, you can review medical records to determine who is most ill and most at risk. But electronic health records are actually tremendously complicated, not necessarily interoperable. At least in the US, we have multiple systems. Different hospitals have different billing practices. And this sometimes gets studied. Journalists like to embarrass hospitals. They'll show that one hospital will invoice for 10 different procedures, whereas another hospital only invoices for 2, and actually what was done was identical. So there's all sorts of eccentricities in the data. And so they thought, well, instead of trying to get into all of that, and when I say they thought, I don't have an inside view. I'm just telling a story about what we can imagine happening. They thought, well, the amount of money spent on someone, A, is the thing that we really want to reduce anyway as the insurer, the person who's paying for this. But B, it's probably a really good descriptor of how sick someone is, right? If we think about just a little bit of domain knowledge in healthcare, we are always told that the huge portion for any person, the spending on their health, all happens at the end of their life when they're most sick, right? Just when you're about to die, that's when your healthcare spending shoots up. So that seems like, oh, high cost seems to mean you're sick for the most part. On the other hand, the problem is that other domain knowledge was not integrated. And the problem really was that there are huge disparities in spending by the race of the patient. And unfortunately, there are all sorts of reasons for this if you sort of look at the sociological pipeline. But even white versus Black Americans who have the same income and the same health insurance will often have different rates of healthcare spending, in part because somewhere along the line, Black people often end up not getting as good care, even when they are able to pay for it. There are studies like if you go to the emergency room and you're Black versus white, the Black people tend to get less pain medication than the white. There are similar results that women tend to get less pain medication than men, and so on. So once you start looking into this, you actually find out there are all sorts of disparities. And so I apologize, this is where I'm having a bit of trouble because I have so many windows open. But on the left, what the researchers found is that sort of the algorithm risk score, it mapped very well onto total expenditures. So in a way, if that's what you're looking at and you forget that that's just a proxy, you say, look, I built a very good model. Look at this, it works really well. And for both Blacks and whites, my risk score seems to predict pretty well how much money was spent on them. But the problem is forgetting about this really damning graph on the right, where actually if you go back and try to do some more accurate measure of illness, of actual qualitative health information, we can see that for the same degree of illness, and of course it can be difficult to construct these measures, but if you do, the same degree of illness actually leads you to having quite a bit less spending for a Black patient relative to a white patient, and that's for all risk levels. So this is sort of the danger of proxies. This is one of the things we need to worry about. Another thing we need to worry about, and I'm trying to give you these even as sort of actionable lists. They're not complete lists. It's really difficult to build a list, but if you just jotted down sort of 10 things and went back to your own work, and I'm not saying your work has these problems, but it's something to keep in mind, both with past projects and projects moving forward. So another problem you can run into is incompleteness of data sets, right? And this is also just a reality. You are never going to have a complete data set. On the other hand, you want to think about the systematic ways that your data set might be problematic. So one problem is the incompleteness of data sets, and they can be incomplete in different ways. So these were some examples I thought about, for example, with credit scoring, right? Because often when, especially before it was regulated, there would be many studies finding that for credit, women were not given equal access as men were. Racial minorities were not given equal access as whites were. Again, I'm talking about the US context because this is what I know, but we can expect this is likely reproduced in various ways in every country. So firstly, we only record successes where we have provided the opportunity to succeed, right? So if we're studying a decision-making process, for example, we're trying to predict who can or can't repay loans. Consider that individuals can't repay loans if they aren't given loans. So if you have a data set where a certain kind of person was never given a chance, or was only given a chance at very low rates, which means we're only going to get a fairly inaccurate, noisy measure of that type of person, then our data set has foregone conclusions built into that. Likewise, individuals can't graduate from university if they aren't university, right? And this to me sounds very familiar with what I heard from my grandmother when she thought about going to medical school. And she was told by the medical school dean something like, oh, well, we only had one woman and she went off and had a baby. So we can't admit any more women, right? So if you're only giving, they gave the one woman a chance and then decided she was the prototype for everyone. And so if you don't give enough people the opportunity to succeed, you have a very incomplete data set in a fairness way, like a fairness salient way that's clearly not acceptable for those kinds of predictions. Likewise, sometimes a label means different things for different groups. And so an example that comes to mind here is perhaps police officers selectively cut people a break with unintentional racial patterns. Notice that most of this, or even all of this, doesn't need to assume there's any animus. There's no intentional discrimination. But it could be that a police officer first happens, and perhaps a white police officer, right? Because there's also some affinity between people. This is just documented. Look at the sociology. Perhaps first the white police officer runs into a white teenager, and the teenager is, doing some sort of antisocial behavior, egging someone's house. And the police officer says, I really don't approve of this. Bad kid, bad kid. But the kid kind of reminds him of himself. He relates to the kid, so he calls the kid's parents and lets the kid off with a warning. And then later in the same day, he runs into a black kid doing the exact same thing. And maybe just something about that lack of in-group membership, something completely unintentional, the police officer says, oh, it seems like you're going down the wrong path. You need to be taught a lesson. So remember, humans are doing a lot of the labeling, right? So he might then give a different label for that behavior, right? So it could be the same underlying behavior, different label. Or we can imagine another scenario where maybe the white kid was actually doing something slightly worse than the black kid, but they ended up getting charged with the same crime. So these are just events we can totally imagine happening, mostly due to unconscious bias. It doesn't even have to include somebody actively trying to create bad data sets. So in addition to those problems, there's also a danger of labels, right? Supervised learning remains the dominant form of what most people do with machine learning, but we have problematic labels, and that's where a lot of the unfairness comes from. There's this quote I like from Judge Easterbrook a lot. He's a fairly prominent US judge. And he said, depictions of subordination tend to perpetuate subordination. So if we are learning from past data sets that are unfair and we're using that to reproduce unfairness, right? This is a very common critique of machine learning, one of the first ones we hear about. But But what it means is that sometimes if we're just going to say at the end of the day, as long as the label is correct, it's correct. Well, that's also a problem if we remember that those labels themselves can have unfair judgments built into them, right? And so relatedly, who says the labels are correct anyway? And here's an example. I went to Google Images. I know in all these fairness talks and news coverage, people love to hate on Google Images. I don't mean to say that they haven't built a really helpful, amazing project that has enriched our lives, absolutely. But there are some really basic problems with this. So this is a search I did in April 2020. I searched for unprofessional hairstyles for work. And look what comes up. I only see women, and I see quite a few more Black women than I see in other kinds of searches, right? So usually minority groups don't tend to appear as often in the Google searches, but somehow when I'm looking for unprofessional hair, they pop up. Now there is a caveat, which is that many of the images I'm showing you here actually appeared in news media articles about Google search doing this. So it's actually quite meta now, where I'm trying to show the bad behavior, but instead I'm finding news articles about the bad behavior. That's another form of problem, though, right? It is still continuing to perpetuate the unfairness, and we can think about how this relates to some legal terms. For example, in the EU, the right to be forgotten would partly sort of help to fix this, right? So maybe if there were some right to be forgotten for Google's errors and they could fix themselves, maybe we could get over this. But clearly there are problems with the image search, even in April 2020. And I would say, given the prominence of this issue, I would have expected Google to do something about this. It's a little surprising they haven't, which again is me trying to convince you that this is important. It's much discussed, but people don't tend to act on it, right? It gets even worse though. Look what happens when I add men to the beginning of my search string, right? So now I do men unprofessional haircuts. I thought, okay, let's give Google Images another opportunity. But if you look at this, actually there are still plenty of women appearing looking for men unprofessional haircuts. And this is also where we get into the labels being correct. So I can imagine my grandparents would say something like this, or this is unprofessional. But it's all a matter of context, right? And culture. I think nowadays in many of the environments where we all work, that's probably not true. These are probably perfectly acceptable, in part because in recent decades, we've realized sort of the racial animus that is embodied in these attitudes about hair, but also because the sorts of people who succeed are changing, right? And they're being a little more creative and a little less conformist. So in a way, I see again here sort of a failure of the data to evolve, or we're accepting labels from only one segment of society. Maybe that's the segment of society that talks about hair, and the rest of us don't think it's a big deal. We don't talk about it. Those labels then are sort of dominated by one group. And by the way, this guy's a professor at Princeton University, right? So it's also kind of funny to just, be calling someone out as unprofessional when they're a tenured professor at a very prestigious institution. Okay. I'm just having total silence, so I'm assuming we're all good, and I'm just going to keep going ahead. But I remind you, feel free to comments, questions are all welcome.
Yes, I have a question. So regarding questions, like for example, the question you just asked about the unprofessional hairstyle. So do you also assess whether, for example, some question itself is eligible to be questioned as fair or not, or unfair? You see my question? So
absolutely. Yeah. So, and feel free to jump on again. I'll just address that already. I'll talk about that a bit with the data pipeline. But one important question is asking whether the question you want to answer is a fair question. Absolutely, right? Should this question be asked? And even if it's like a fair question to ask, do we have the capability to answer it, which is another important consideration before you even start the data science applied AI process. And it's definitely an area where we don't, something about our corporate cultures and even our academic cultures, we don't see enough pushback, right? Where you get an instruction from management, they may not understand the limitations. And maybe people who do technical work need to give more pushback in the future and say, well, this is not a good question because this is the kind of data we have. Or even to just say, this is not a good model to be building. I'm not comfortable building this, right? And if we could have more guidelines to empower people to do that, we might see less of this, right? So I think that's a good point to make here, right? Just even asking if a hairstyle is unprofessional already has some judgments loaded into it.
But by doing so, we're also restricting, like putting restrictions on, for example, what machine learning is, what are we going to allow machine learning to ask, you know? So yeah, I mean, we feel that it's not bad to, you know, to just give like machine learning maybe some you know, rights to ask maybe any question, and then maybe inform, for example, the audience that, you know, this question is subjective, is like, you know, like it's an opinion. For example, the answer is actually an opinion. It's not like, you know, there is no yes or no. There is, you see. So just yeah, another viewpoint on the subject. You see.
So would this be something like putting a disclaimer on a product when you release it?
So excuse me.
So I'm thinking one actionable way to do what you're discussing is you can just have a disclaimer, right? So this product tells you whether your haircut is professional or not, but obviously that's a subjective opinion.
Yes, exactly. Like that's what it is actually. Yeah.
So I think that could be interesting. I am not aware of work looking at how people would respond to that, but one concern I would have is just the enormous degree of automation bias and algorithmic deference that even if people know it's subjective, that they may not actually act in a way that reflects that.
Yes.
Begin to treat it as more.
Yeah, classify questions and problems. Yeah, classify between, you know, yeah, that's it.
So, and this is something I want to talk about a bit later, but just this, apart from the product, you often have to think about how will it be used downstream, and that's just as important.
Yes, thanks.
Thank you. So more problems with labels, and this is not an exhaustive list, right? But labels often imply all sorts of, just apart from sort of the biases we see in society that we're trying to get rid of, there are just cognitive biases and linguistic biases, these conventions about how we express ourselves. So in speech, it's often prioritized labeling unusual standard elements of a photo, right? So when people are doing work on image recognition or linking NLP models to images, we tend to only highlight the things that are unusual. And so people are starting to do work on this, but an example related to bias is we might say a surgeon versus a female surgeon, right? Implying that the female element of being a surgeon is unusual. So if I had a male surgeon, I wouldn't say male surgeon, I would just say surgeon. And a less loaded example of that would be, I would never say, look at all those yellow bananas, I would say, look at those bananas. So that's one problem, right? Is we'll only highlight in speech or in our labels the unusual bits. And likewise, we don't even have labels for all representative groups, right? And especially as many Western societies, more liberal, people have sort of more niche categories they're belonging to. We might not even have those labels, even though those labels have social importance. There's also the essentializing tendencies of machine learning in general, right? So if you take a slightly biased data set, train it with a logistic regression, you'll often get an even more biased data set. And this is true for most machine learning models. If you don't have some kind of fairness intervention, you will take your bias and you will make it worse. And this is something that continues to be true. Again, image search is an easy target, but it is not the only place we see this problem. But Pew Research did a study in just 2019, and they found that for 57% of occupations, image searches suggested they were more male-dominated than they actually were. Interestingly, this was a problem that was already highlighted with Google image search as early as 2015, when people pointed out that the percentage of photos of CEOs that were women was far lower than the real percentage of women who are CEOs. And this connects back to that Judge Easterbrook quote about images of subordination perpetuate subordination, right? So you can also have the problem that these image searches are then affecting us, which affects the data, which perpetuates the cycle, right? And so these things are seeing something bad, and in many cases, even making it worse. Another problem, or another reason we see these problems with fairness, is the focus on KPIs. Why is that a problem? Because for bottom line considerations, it's almost always going to be your model's accuracy that matters the most. What's the problem with that? Well, accuracy tends to be correlated with discrimination for a number of reasons, right? But they're sort of in mathematical tension. As your discrimination goes down, your accuracy also goes down. If you have more discrimination, that's not enough to get you accuracy, but when you look at the trade-off, that's what you see. Relatedly, another problem you will run into is with the security of your models. Accuracy is also correlated with model fragility. So for the most part, although this is still up for debate, it's not a mathematical certainty. Accuracy is also correlated with model fragility. So when you're trying to build models that are robust to adversarial attacks, also turns out there that you will usually take accuracy hit. Why do we still see this focus on KPIs? Because the KPIs are our bottom line, right? That accuracy is the number that we all use to pay our salary. Unfortunately, my theory is that until we have some sort of formalized legal requirements, this will remain the case, right? When we think about people in the marketplace trying to do their job well, for us right now, that's all about accuracy. But if we start seeing legal requirements relating to discrimination or legal requirements relating to robustness against attacks, we will then probably have some KPIs and people turn more attention to that, and that will be great. Another one, this one you're probably aware of, as far as this can take you off course, even just building a model that has nothing to do with a social issue you'd be worried about, but high dimensional data sets will always have dangerous correlations. In the US context, it's incredibly difficult when you have wide data sets not to have proxies for gender, for race, for religion, for all sorts of categories that should be protected. If you haven't heard the term redlining, that's what I want to introduce you to here. That can be sort of your shorthand for this problem. In the US, after the civil rights movement of the 1960s, we had the Fair Housing Act and Fair Credit Act, which required that people of all races be given equal opportunity to access housing and also access things like mortgages to pay for their housing. This is also the primary source of wealth in US society. As you build up wealth over your lifetime, being a good, responsible citizen, you tend to put it in your house, right? So this is sort of the core of our social contract in a lot of ways. So when banks were no longer allowed to just look at your race and use that in their decision, they first decided, oh, well, we're still not with the program. So what we really want to do is find another way to do that. And it wasn't difficult because we have still now really extreme geographic segregation with housing. White neighborhoods, black neighborhoods, this continues to be an unfortunate reality. The problem is that meant you could just look at somebody's zip code and have a very indicator of what their race was. And so what banks did for a long time was they didn't facially discriminate. Instead, they redlined. They used zip codes and they said, oh, we just don't provide mortgages in these zip codes. And usually they'd say something like, oh, they're just not, these zip codes are not good. For whatever reason, these communities, they don't pay back. But what they really meant was that they knew about the racial composition. This was eventually outlawed in the US, but only in the 1980s. So it went on for decades after the civil rights movement. What I find interesting about this is I recently saw a recidivism prediction tool, right? So predicting if somebody will reoffend with crime, that was implemented in the UK. And in the UK, they went ahead and also used zip codes. So interestingly, we see even in 2019, despite the lessons of redlining, we see zip codes. We again see these uses of proxies. And actually, there was an academic paper written about that program, and they defended it as saying, well, maybe certain zip codes are, sort of less morally robust, less culturally robust, and that's why we see a reoffense there, which might sound tempting, but then if you look at it from the discrimination angle, it sounds like a new way to discriminate. So you always want to be on the lookout for proxies and correlations. Relatedly, and because of this structure inside data sets, we need to remember that blindness does not produce fairness. Blindness can be deployed strategically to exacerbate unfairness. So an example of that is after the civil rights movement in the US, some companies started requiring a high school diploma. It was completely related to the work people were doing, for example, preparing food in a kitchen or janitorial or what have you. And yet they knew that a high school diploma correlated really strongly with being white, and that's why they were doing it. So this actually prompted the courts to recognize that you can also have discrimination even where you claim to be race blind. I also want to highlight right, that sometimes race blindness can be a good thing. So some US states have actually used this as a way to diversify universities by promising that top 10% of any high school class can go to any university in the state. And the reason this works is because of that geographic segregation of races that we have. That means that some schools will be almost 100% some racial minority, which means that you are providing a route through. Now, whether that's a good route or not is a different problem. But I just want to point out that blindness is not always a bad thing, although usually it is for our machine learning models. Let's remember, finally, that by definitions, minorities are less attended to by machine learning algorithms. If you don't have some kind of intervention to actively look for where minorities are being slighted, what your model is going to do, because it has less training data, is it's going to bend to the majority. So what does that look like in a simple example? I took these from Professor Aaron Roth, who teaches a course on machine fairness at the University of Pennsylvania. If this is what all of our data looks like, you might think you have a nice linear model. Let's say you're trying to do some kind of university admissions. On the other hand, your minority group might look like this, and there might be a completely different line that suits them. But if you fit on the majority line, you're actually going to mislabel the entire minority population, which feels incredibly unfair to me, right? So this is all to point out that a lot of what we see in machine learning is that blindness is not a good thing, right? What we actually need is domain awareness, and an awareness that machine learning sort of inherently does not privilege minority groups unless you give them an incentive. Okay. So we'll talk briefly about defining fairness and then move on to the fairness pipeline. I won't go through this in detail, but I wanted to make you aware that there are major classes of fairness definitions, and these are the big three. Demographic parity, that basically says we think that outcomes for each racial group or gender group or any other grouping you think is important should be equal. This can be incredibly hard to enforce. Often there are different baseline rates for different behaviors we're interested in. Some of that can even be explained by discrimination, right? So you get into all these questions of causality and how you can make these equal and should they be equal. So sometimes people try to move something a little bit more individualized and they say, okay, maybe we can't have equality for all groups from our model, but we're going to look for counterfactual fairness, which means that if I take an individual and I swap their sensitive attribute, I make a woman a man, I make a white person a black person, and so on, I shouldn't see a difference in outcome. And that's how I establish counterfactual fairness. And finally, we have equality of odds. This basically says that the probability of the false positive and true positive rate of individuals who have positive rate should be equal. The equality of odds, well, let's just try to match reality as well as we can, and to match reality equally well for different groups. So if you're thinking about sort of how interventionist your fairness approach is, demographic parity is sort of the strongest fairness definition. It does the most intervention, whereas equality of odds demands the least intervention. That is sort of just saying, oh, let's change our error rates a little bit, but huge for the reality. Which one is appropriate will depend on your underlying beliefs about your system. For example, if you think your data is fundamentally fair and you just want your model to reflect that data rather than creating new biases, you'd go for equality of odds. On the other hand, who says your label is fair? And if you believe deeply unfair, you might want to enforce demographic parity. You should also know that there are fairness inconsistencies, right? Especially when you look at different measures of fairness, they can conflict. And that can happen either when you're looking at group fairness versus individual fairness, or even when you're just looking at different measures of group fairness. So for example, you cannot equalize both false positive and false negative rates across different groups at the same time. Even if you're going to have an intervention, you have to choose. Will they all have the same false positive, but different false negatives, or vice versa? Which one you choose will depend on which mistake you think is more costly, right? It demands domain knowledge and some thoughtfulness about how you do this. We also see that group-oriented definitions of fairness come into conflict with individualized definitions of fairness. For example, if you want to have demographic parity, but you're also looking at some kind of consistency ranking in your model, you will see that you cannot preserve both of these things at the same time. You will indeed need to make choices. I won't go through the algebra here, but I would point you, for example, to a very accessible paper by Chulachova from 2016 She's a mathematician at Carnegie Mellon. So when a very famous article about Publica, which is a criminal scoring system in the US, came out, they found that the false positive and false negative rates for whites and blacks didn't match. And everyone was really scandalized and said, this is so discriminatory, it's very upsetting, and so on. Absolutely, right? On the other hand, what she pointed out and what others pointed out too is that you can't have scores that are both responding to individual notions of fairness and group notions. So in this case, what has usually been used is calibration, right? Which is what we see here and what Compass had already passed on. People did calibration and said, well, if you look at a particular score, does that mean the same thing for an individual, whether they are white or black? And indeed it does. So for example, if you have a Compass decile score of about 5, whether you're white or black, your probability of recidivating is just under half. And that's true regardless. So traditionally, people have felt very good about instruments when they are calibrated, right? When the score means the same thing for a person regardless of their race. On the other hand, the problem is that this leads to shocking disparities in the false positive and false negative rates when you have different baseline probabilities, as you do right now for whites and blacks in the US. You can go second order, third order, et cetera, saying, well, why do we have different baseline rates? But of course, that goes beyond the machine learning models. So I'm happy to share my slides. I just want to highlight that there even is simple algebra to show that these fairness metrics do not line up with one another. I also want to highlight some other values you want to think about in your own work and think about how to make them actionable. You want to think about things like consent. Now that GDPR applies to you, you probably have been thinking about that, but you want to think about it more broadly, right? And GDPR does not cover the full range of what can look like consent. You want to think about the material words for production and distribution. This is something people are talking about even more, right? What will happen if people become owners of their own personal data? What would that look like? Privacy and security, tremendously difficult and complicated. The only thing I want to highlight is that data scientists often know nothing about this and unfortunately incorporate none of these practices as a result. And that's something also when we're thinking about fairness that we should probably rethink. Fiduciary duties also, right? You can wonder, is there some kind of power imbalance? If you, a data scientist, know more information about a person or a certain aspect of their behavior than they do, at some point, there's a power imbalance. Do you have some obligation to those people? And this goes back to the question that was asked earlier. What kinds of questions should we ask? Maybe we should think about these power imbalance issues when we're choosing our questions. So fairness interventions, what can we do, right? So that's all background. That's not nearly enough background, but I think it at least gives you some kind of bullet list to go through your work. So if you go through your work with those bullet lists and then you say, oh, there's something I'm not happy about, what can I do about it? This is where you think about a fairness intervention. Most of you, I think, are practicing data scientists, so you know this data science pipeline. I stole this image from Wolfram, but I think it's general enough to describe a lot of our workflows. What I want to highlight is that there are all sorts of opportunities to think about fairness in the applied data science and applied AI pipeline, starting with the purpose of the model, right? So that's something we touched on earlier. When you're thinking about the purpose of building a model, that comes down to, is the question I'm asking a fair question, or is it a question that in some way is going to undermine people's autonomy, take advantage of people who are in a weak position? So an example of that, right, we often see papers on arXiv where researchers say, hey, I used a convolutional neural network to identify depression. That can sound like a great thing, like a great opportunity for mental health professionals. But to me, I also wonder why these papers never have an ethical component explaining how they would prevent this work from being used by online advertisers, people trying to peddle all sorts of shady products and such, right? So when you are developing a model, think about how it can be used downstream, even if it works. And then secondly, think about whether you can even achieve the purpose you are hoping to achieve. So to remind you, we discussed that Science article that came out in October 2019 where a proxy was used. If your best answer is going to be a proxy, you should ask yourself whether it's likely that that will be misunderstood further down the pipeline and misapplied. Data selection, another area where you can have fairness interventions. This is where issues of consent come in. GDPR is certainly taking care of this, but you should also think about what kind of data and uses people expected you to use, right? And to realize that they are less sophisticated than the data scientists. So perhaps there are elements of the data selection that an ordinary person wouldn't have anticipated, even though they were obvious to you. And then that goes back to whether their consent was really informed. So when you're thinking about data selection or thinking about data that perhaps you bought that people might not even be aware that you're buying, these are sort of more ethical issues, but you can think about them as a fairness intervention in the sense of deciding, oh, that would not be appropriate data to use. I'm going to leave it to the side. Likewise, if you think that a data set is extremely riddled with sampling bias, or simply reflects an incredibly discriminatory world, such as you might say about policing data or income data, sometimes you might decide not to use that, right? And rather to create a fresh data set that might show a better reality now, rather than using a data set that may be old or that may reflect old biases. Okay. Then you can get into what are known as pre-processing, in-processing, and post-processing interventions. I'll talk about these briefly in subsequent slides, but these are basically whether you want to take active coding interventions on your data itself, on your training process, or on the output of your model. Once you've done that, though, there are still more steps you can think about taking, right? So performance monitoring and stress testing. One important element that the legal community is very interested in right now is the fact that the degree of discrimination you will see in a model is going to depend on the underlying structure of the data. So people have been looking at this, for example, with credit modeling and pointing out that, for example, in the US, different regions have different racial compositions. There might be sort of different economic patterns. And it can be that a bank that develops its algorithm for one region might find no discrimination in that region. It operates well, but they might give that algorithm to another bank, sell it to another bank or be acquired and have this algorithm rolled out more generally. And an algorithm that works well for Florida and doesn't necessarily result in discrimination could very well be redeployed in Michigan, where that's not the case, and where it does lead to sort of drastically disparate impacts for different genders or different racial groups. So that comes down both to performance monitoring and also stress testing, right? Where you should imagine different population structures that your model might encounter and actively look for hypothetical situations where you can stress test your model. And then finally, you should think about black box auditing. Many methods have been developed for black box auditing. This is sort of an ongoing active area of research where the goal is to have people come from the outside and sort of kick the tires on your model without knowing anything about it. And that can be good because they won't have conceptual prejudices about what they expect to find in your model. And they're also not the owners of the model, so they're not protective of it in a way that I know I'm protective of my work, right? It's a form of peer review where you wouldn't necessarily need to give away your proprietary software and your proprietary information, but you could nonetheless have outsiders come in and draw some reasonable conclusions and do reasonable tests about your model. Okay, so pre-processing, in-processing, and post-processing, I would think are probably the most actionable for this community to the extent that you're interested in doing fairness interventions. Pre-processing is the optimal fairness intervention if you can do it. So some of what interventions you choose will depend on what you have access to. With pre-processing, if you have data and you are fully allowed to change the labels on that data or to change the way you represent that data, then this can be a very good approach. And I've listed a few examples of how people process. The first one is flipping sensitive attribute labels on individual data points. So essentially, you just inject randomness. You look at a data set and say, well, maybe there is, for example, some gender discrimination. So what I'm going to do is I'm just going to randomly flip some of the male and female labels. And that way, I'm not sort of bringing my judgment in. I don't have to define a metric of what's discriminatory, but I just say, well, since it shouldn't matter, then I shouldn't be losing any important information by randomizing this sensitive attribute. Another example that's more interventionist is you can reweight your data points. So in this case, you actually do take a more active stance and you say, okay, I believe that outcomes for all groups should be more equal. So continuing this example maybe of credit access and a gender discrimination scenario, I would say, oh, I see that women don't get access to credit as often as men. I am going to re-weight the cases of all four groups. So I'm going to downweight the unsuccessful women, downweight the successful men, and I'm going to upweight the successful women and upweight the unsuccessful men until I force my model. In this case, it's just an average. So this is not the model you'll build, but just the average, which is a kind of model. I'm going to force that model to have no disparate impact. So that's extremely interventionist. In some cases, there's an argument that that might not even be legal, right? So you can run into questions of, is this consistent with the regulation? Then there are more sophisticated approaches, such as learning a representation space. And when you learn the representation space, you can do a few things. You can learn a representation that minimizes the information about the protected attribute, or you can learn a representation space that balances some other metric. It could be a disparate impact metric. It can be an individual fairness metric plus a disparate impact metric. You can sort of mix and match and even put more than one fairness definition in if you're just trying to optimize without achieving perfection. So I also have some recommended reading here. And like I said, I'm happy to share my slides. So these are sort of two of the most commonly followed and applied pre-processing examples. In processing is even easier to understand. For the most part, when you're in processing, what you're going to do is modify your loss function to reflect a discrimination penalty. And how you do that can even be up to you. Perhaps with your domain knowledge, you can put in something quite specific. You can also use some published results that people have come up with. So apart from a loss function or a regularization term, another interesting example people have used is using adversarial learning patterns. But rather than using this to create some kind of generative model, what your adversary is doing is it's not sort of using the first model's output and calling it fake or real, but it's going to use the output from the model you're really building. Your adversary will come in, look at that output, and determine whether that output allows it to produce a good prediction of race or gender or whatever you're interested in. So that kind of model has also been used. That one's really nice because it's very flexible. You can use it for regression. You can use it for language. So that can be very helpful if you do all sorts of work. And finally, post-processing examples. In processing is most appropriate if you can't change the data, but you can change how you train your model. Post-processing means you don't have access to the data, you don't have access to the model, but you in some way still have ownership for deploying this model. If you find yourself in this situation, what you would consider doing is post-processing. Unfortunately, state of the art with post-processing remains very depressing because mostly what you're doing is flipping labels of the outcome at random. So when you post-process data, a data model, right? When you post-process an AI model, what you're essentially doing is making the model worse by injecting some randomness and injecting that randomness systematically so that you reduce some kind of disparity between groups. And how you define that, again, will depend on your fairness definition. Most of the work that I've seen done here uses the equality of odds definition, where we're basically just saying, for those people who should have had a positive outcome, we want the false positive and false negative rates to be equal, or possibly just the false positive, depending on our definitions. Okay, so I'll just wrap up with a few minutes on state of the art, and then we'll look forward to any questions you all have. Fairness definitely remains an art, and it may remain an art forever, but here are some technical reasons for the moment that it feels very much like an art more than a technical set of solutions. Most methods don't have closed form results. Most methods don't have guarantees, right? So you might use a method and it's not every method is 100% guaranteed not to introduce additional discrimination. And no method is guaranteed to only reduce your accuracy by a certain amount. So if you are trying to sell fairness interventions to management and they want these sorts of guarantees, this is where you would have to step in and do auditing and post-processing rather than offer closed form guarantees of any kind. Unfortunately, we still need that in the field. Most methods are achieving one of many definitions of fairness. So there is no method, and this will continue to be true, right? This is the no free lunch theorem. There's not going to be some magic fairness method where you can just say, okay, we use this method, we're good people, we are fulfilling all our requirements. That's not going to happen. There are also new ideas and problems to tackle for fairness, right? So if there are sort of, these are your areas of interest, these problems are not solved, maybe you can solve them, but there's no definitive answer. So some things that are going on in the field, people are mostly working off of old data sets. So most of the papers in this field use things like the German credit rating score, which is decades old. Even the Compass data set is actually reflecting data from a decade ago. There's also an adult income data set that is also, I think, 30 or 40 years old. So these data sets where we're building our fairness methods are not being built on state-of-the-art data. Also, fairness interventions require assumptions about causality, but we have this problem of indeterminacy. We don't have models yet that can at least rule out certain methods of causality, even though fairness is ultimately linked to causality, right? Are people being judged because they deserve to be judged, or are they being judged because of discrimination? Maybe it depends on the context, but right now we can't tell that. We also probably have too many fairness definitions, which can also make it hard for people to act, right? When you want to just optimize fairness and you run into 25 different fairness definitions, it can then be difficult to get over sort of analysis paralysis and just decide what's right for your organization. We still have problems like sampling bias and measurement error. That's going to continue to be true possibly forever, but it would be good if we had more methods that were able to quantify this. We still need those performance guarantees. And there's also this complexity element, right? That what fairness researchers are not doing yet is integrating downstream information about how fairness labels or fairness interventions will then be judged when these algorithms are released in the wild. A bit of legal background, you probably know a bit about this, but we are definitely seeing governments more active with respect to AI in general and data privacy. Of course, these things are intimately linked. I think the EU in general has shown more interest and activity relating to data privacy. And then for algorithmic transparency and ethics and things like this, which more directly impact fairness, we see some preliminary documents, but nothing coming into force legally. In the US, on the other hand, we see very little action on data privacy for the moment. But on the other hand, we do have guidance from the White House on the use of AI. And we do have individual states issuing moratoria or even bans on certain forms of AI, most notably facial recognition and automated decision systems. What are some obstacles to affirmative fairness in industry? Well, I would love to actually hear from you if you have feedback for me, how I can address concerns there. But some things I have thought about and talked about with other people are compliance concerns, right? Because most fairness interventions actually require you to look at the label, like you have to look at the sex, you have to look at the gender, you have to look at the religion, the race, and so on. People get very nervous, right? Because if you don't look, that feels good and legal. If you do look, you start having to explain why you're looking. That can make lawyers and compliance people very nervous for good reason. There's a difficulty in choosing between different fairness measures. That's something where it's always going to be an art and ultimately an ethical judgment rather than a technical one. And then finally, there's a lack of training and standardization. There are some trainings now and there are some open source libraries, but it's not like training a neural network where you have 5 different excellent options that are all well developed and people mostly are coalescing around different initialization factors or whatever. There are certain best practices. There's much less of that in fairness, and that's something we desperately need. There's also a COVID-19 angle, right? There's clearly going to be more AI deployed to handle this problem. And I think we're going to see an interesting social debate about what's really appropriate, not just with data privacy, but also possibly with automated decision-making tools that might quarantine people, that might give people a risk score, that will have very real impacts on our freedom of movement and on our access to healthcare and things like this. Hopefully it doesn't get too scary. But in a way, I think this is going to highlight AI fairness issues even more when countries do start opting for these tools. I do want to highlight some options that are out there. So there are 3 tutorials I would very much recommend. This one at the top, algorithmic bias, from discrimination discovery to fairness aware data mining, I would recommend that you start there. This is actually from 2016. So these scholars were actually really active and early to this movement as far as producing an accessible training that still gives you a good grounding in theory. More recently, we have a fairness training from Microsoft and Google that's actually also quite excellent and showcases some of the tools, the open source tools they are highlighting. IBM is developing another fairness library called AIF 360. Some of the algorithms I discussed today are coded up there. So what's very cool there is they use state-of-the-art published research and implement that. So if you find a paper and you want to implement it, you may even find it already available there. And they are also actively soliciting people to work on that. As Laura mentioned, I have a book coming out later this year called Practical Fairness. And the goal of that likewise is to just give people something actionable so that if you want sort of a plain vanilla fairness intervention, you can just go there, understand how it works and use it. Because even if it's not the best one, it's good to have something rather than nothing. Also, it's of course an interesting time for AI. So this article last year came out in April 2019, Machine Behavior, where people are arguing that we should basically have sociology and economics just for studying algorithms. So that's something to keep in mind with your own work, how complicated the downstream impact can be. And this paper I would also really recommend. This just came out a few days ago, Toward Trustworthy AI Development, Mechanisms for Supporting Verifiable Claims. That's interesting both from a technical angle of thinking about, again, how can you better control your work and understanding its impact, but also thinking about once there are sort of agreed upon mechanisms for developing trustworthy AI, that's also going to become an ethical duty and possibly a legal duty to be thinking about these things and ensuring these things. So thank you everyone for listening to the talk. I am looking forward to your questions and also any feedback. And likewise, if you want to get in touch after the talk, I would encourage you to reach out by email.